So once again, let's think of yourself as some type of ancient philosopher / mathematician who's trying to extend mathematics as much as possible and trying to make sure that you're not being lazy and leaving things undefined when you might be able to define them. But whenever you start extending mathematics, especially in the realm of multiplication and division, there are a few things that you hold dear to. You feel that if you define some type of division operation, that it needs to be undone by multiplication. This is close to your heart. So you would like to assume that any type of division operation, if you start with some number, and if you were to divide with a number over which that division by that number is defined, so if I were to divide by some number and then multiply by that same number, that this should get me this original number right over here. This should give me x right over here. And this happens with when we just multiply and divide with regular numbers. If I get 3 divided by 2 times 2, that's going to get me 3. If I say 10 divided by 5 times 5, that's going to get me 10. The other thing that I want to assume, this is very close to my heart, I feel that any type of definitions I make have to be consistent with the idea x times 0, and I'll use a dot for times here. X times 0 has to be 0 for any x. So these are close to my heart. If I'm going to extend mathematics, these two things are things that cannot be contradicted, cannot be untrue. Now, with that out of the way, you want to start exploring the divide by 0 question. So the first thing that you say is, well, let me just try to define it. So let's assume that I have, so let's make a further assumption that x is some non-zero number. X is some non-zero number. And let's just say, well, maybe the best way of finding out what x divided by 0 should be, how I should define it, is just assume that it's defined and then come up with any results that I might, or maybe I'll even be able to solve for it. So let's say that x divided by 0 is equal to, let's say that it is equal to y. Well, I'll use a different number just to not get you confused with this up here. Let's say it's equal to, let's say that it is equal to k. Well, if this is true, and if we're defining what it means to divide by 0, then we're assuming that if we multiply by 0, we need to get our original number right over here. This is something that we are not willing to contradict. So let's see what happens. X divided by 0 is equal to k. On the left-hand side, I'm going to divide by 0 and then multiply by 0. Well, if two things are equal and if I do something to one thing, in order for them to stay equal, I have to do it to the other thing. This has to be equal to that. I have to multiply both the left and the right-hand sides by 0. Well, by this assumption that I'm never willing to give up, this left-hand side right over here must be equal to x. This must be equal to x. And by this assumption right over here that I'm not willing to give up, this right-hand side right over here must be equal to, 0. But I just hit a contradiction. I assume that x does not equal to 0, and now I'm being forced to say that x equals 0. And I'm not willing to give up the idea, either of these ideas. I'm not willing to give up the idea that if I'm defining what it means to divide by 0, or if I'm defining what it means to divide by anything, that if I then multiply by that something, that I should get my original number. And I'm not willing to give up the idea that anything times 0 is 0. So out of all of these things, the only thing that I can give up is this right over here. And I'll say, well, I guess k will have to stay undefined. This whole contradiction happened because I attempted to define what x divided by 0 is. Now, with that out of the way, you're like, well, okay, this was the situation when x does not equal 0. But what about when x does equal 0? So let's think about that for a little bit. And once again, I will try to define it. So I will assume that 0 divided by 0 is equal to some number. Well, once again, let's just say it's equal to, k again. And so once again, we're going to try to do the same logic. So I'm going to rewrite it again. 0 divided by 0 is equal to k. And actually, let me color code the zeros. So that's a magenta 0. This is a blue 0 right over here. And once again, I'm not willing to give up the idea that if I start with a number, x, I divide it by something over which division is defined, and then I multiply by that something, that I should get my original x again. Can't give this up. Otherwise, it doesn't seem like a good definition for division. So what I'm going to do is I'm going to multiply the left-hand side times 0. And by this property that I'm not willing to give up, the left-hand side should simplify to this magenta 0. This should simplify to this right over here. But once again, anything I do to one side of an equation, in order for the equation to hold true, I need to do the other side of the equation. If these two were equal beforehand, any operation I do to this, in order for it to still be equal, I need to do to that. So let me multiply the right-hand side. Let me multiply the right-hand side by 0. So on the left, I get 0. I just get this magenta 0. And on the right, I get, I could just write a 0 here, but I won't simplify it. I get k times 0. K times 0. Well, this I see right over here. This actually is not a contradiction. This is actually true for any k. This is actually one of my core assumptions that I made in my mathematics that I'm not willing to give up. So this is true, and let me write it bold. This is true for any. This is true for any k. It's not a contradiction, but the problem here is I wanted to come up with a k. I wanted to almost solve for k. It would have been nice if this turned out to be 0, or if this turned out to be 1, or this turned out to be negative 1. But now I'm seeing that, given the assumptions up here, this could be any. This could be absolutely any k. I cannot determine what k this should be. This could be 100,000. This could be 75. It could be anything. True for any k. I cannot determine what k this should be. And that's why when you get a little bit more nuance in early math, people will say, well, 0 divided by 0, well, we don't know what that's going to be. There's no consistent answer there, so we're just going to call it undefined. There's no good answer that seems to be better than any other answer. But now we see a little bit of nuance here. 1 divided by 0, you just couldn't define it. It led to direct contradictions. 0 divided by 0, it could be anything. You can't determine it. And so that's why, as you get to higher level of math, and you'll often hear this when you take a calculus course, we say that 0 divided by 0 is indeterminate. Indeterminate.